The first part of this video demonstrates batch activation of HB2, where two things are going to happen at the same time. The red line is going to trace the absorbance or colour intensity of the solution during the activation process, and the blue line traces the pH swing. We will go over this graph slower and in more detail during the next part of this demonstration. The beaker contains 900 ml of ordinary city water. To make a concentrate of 3000 parts per million available bromine requires 4.9 ml of HB2. The procedure is written on a document on the stabilizedbromine.com website, but to see it with your own eyes is a lot more fun. The pH of 7.94 is typical for tap water in this part of the country. That syringe is a little jammed. It is not dispensing very smoothly. Next comes the sodium hypochlorite bleach. pH 1.71 to start. The blue line right-hand y-axis defines the pH. The red line defines the absorbance or colour intensity of the solution and is measured using the left-hand y-axis. Two things are happening here. The absorbance of the solution, the colour intensity, is intensifying, and two, the pH increases as the sodium hypochlorite neutralises the acidity of HB2. The colour is due to the formation of bromine and is complexed as the perbromide ion Br3-. The colour reaches a maximum around here, pH 5.16, but look what starts to happen next. The perbromide hydrolyzes to hyperbromous acid, which has little absorbance at 400 nanometers, so the colour intensity starts to decline. So, watch the solution and follow the red line. As the pH approaches 7, all of the perbromide is hydrolyzing to hyperbromous acid, which is colourless, as shown by the decrease in the absorbance of the solution. This activation is taking place slowly, on a batch basis, so that the pH and absorbance transitions can be observed as we understand the chemistry occurring. Obviously, this batch activation is impractical on the plant level, but there will be a demonstration of a fast activation a little later on. There, it is done. All of the bromide ion introduced as HB2 is in the form of hyperbromous acid, 100% conversion. This activated solution contains around 3000 milligrams per litre of available bromine. This solution will be diluted typically between 10 and 13-fold to give a 280 to 220 milligrams per litre solution of available bromine that will be typically sprayed on a beef carcass or knocked hide. Analysis. We'll start with 97 millilitres of deionized water. Two mils of glycine solution, 10%. Activation of HB2 with sodium hypochlorite bleach means there is a possibility that some of the halogen may be in the form of hypochlorous acid or hypochlorite, and some in the form of hyperbromous acid. Clearly, it is desirable to have all of it in the form of hyperbromous acid, and minimize or eliminate the amount of hypochlorous acid hypochlorite ion present. To differentiate the two halogens, the glycine modification of the DPD analysis is performed. Any chlorine species present in solution reacts with glycine to form N-chloroglycine, which does not respond to the DPD indicator shortly to be introduced. Mix. Then 1 ml of the diluted activated solution. It is important to remember that this is the analysis of the 10 to 13-fold dilution of the solution that was just activated. It should be around 280 parts per million of available bromine. Mix again. Take 10 ml of that prepared solution into the sample cell. Wipe the sample cell to be free of water droplets or fingerprints which can obscure the passage of light through the cell. Zero out the instrument. One pack of DPD free chlorine reagent. It is very important to use the DPD free chlorine reagent at this stage. Do not use DPD total chlorine. Shake to mix. Wipe the vial as before. Place back in the colorimeter and press read. Make a note of that number. That number is going to be reflective of the amount of bromine that's in solution. Now we're going to see how much chlorinated species accompanies the bromine. We're going to add a few crystals of potassium iodide to liberate the chlorine from the N-chloroglycine complex to react with the DPD reagent. Back in the colorimeter after a wipe of the cell again. Place the shield on to protect from stray light, and then follow this calculation. The diluted activated solution contains 285 parts per million of available bromine and just 1 part per million of chlorine. That was a very good activation. Fast activation. This is going to demonstrate what happens in practice when activation takes place continuously in a pipe of flowing water. Imagine this slug of HB2 represents HB2 being continuously injected into the water flow. The low pH conditions is registered on the probe as before. Always add the HB2 first to eliminate the possibility of scale formation with high pH bleach. Immediately after the HB2 injection, the bleach is injected into the same pipe of water containing the HB2. Complete and rapid activation. The acidity of HB2 forces the bleach to be in the form of hypochlorous acid rather than hypochlorite anion, Hypochlorous acid oxidizes bromide ion 1.7 million times faster than non-acidified hypochlorite ion, which would be the case if sodium bromide was to be used in place of HB2. Again, a 3,000 parts per million solution of available bromine is formed, which requires a 10 to 13-fold dilution prior to use on an animal carcass or hide. Safety considerations. The activated solution of 3,000 parts per million of available bromine is pH neutral and quite safe to handle. I even use it as a hand sanitizer. Remember that this is the solution that will be diluted 10 to 13-fold prior to use. It does not dry or chafe the skin and leaves hands with a fresh smell that is unlike what happens when hands are exposed to sodium hypochlorite bleach. Next is a reproduction of an incident wherein bleach is inadvertently added to a container of HB2. Pure HB2 goes in the flask first. Now for the bleach. The red coloration of elemental bromine should give the operator making the error a visual indication that something is wrong and to stop the addition of the bleach. Note, the dense bromine fumes never leave the container. HB2 is the safest mineral acid to use around sodium hypochlorite bleach. Any other mineral acid, hydrochloric, sulfuric, nitric or phosphoric, would have yielded very volatile chlorine gas. This would rapidly dissipate into the atmosphere as a green gas, causing discomfort and even injury to employees in the immediate vicinity. For more information on the chemistry, microbiology, analysis, lab procedures and regulatory issues, go to www.stabilizedbromine.com and click on the hyperbromous acid HB2 tab.